Okay, so for question 3, in part 3 of your data analysis project, I'm asking you to conduct a multiple regression. And all that means is it's the same as the regressions that we've talked about before and that you had to conduct in part 2. But instead of having only one explanatory variable, you're actually able to include several explanatory variables and use all of those to try to predict your response variable. So before we had just the one variable. In the previous video I looked at gas price here to predict commute, the response variable. And if you're on a Mac, so this video is about conducting a multiple regression on a Mac, you probably use the slope function and the intercept function and then the r squared function. And unfortunately, you can't just use those functions to do multiple regression, but there is a way to do it. So just follow along here and it shouldn't be too bad. It's a little more complex, but it's not too bad. So the first thing to do is to make sure that you have your three variables that you're going to include in the multiple regression, the three explanatory variables. Make sure that those columns are all together. So I'm going to be using these three here, public transportation supply, gas price, and my indicator variable. And one of your variables should be the indicator variable that you created for question 1. So make sure that those are all together, and if they're not in the right place, you can let's just see, you would just cut and insert cut cells to make sure that they're all together, but I don't want that variable there, so I'll move it back. So the first thing to do is to make a little table or a few labels here like I've done over here. So the first thing is to, in 5 rows here of one column, write labels like this or type in labels like these ones. And this just is telling you that in this row of the output you're going to have the coefficients, which are the slope coefficients, the b's, for each variable, and then a, the intercept, will be at the end. Then the standard error of each coefficient, so that's basically like the standard deviation of the coefficient, but it's called the standard error because it's calculated from the data. It's not based on any information about the population. And then the r squared is going to show up here, and then the cell next to that is going to have some information that you don't need to worry about, so I typed in NA, not applicable. Then the next row, the first cell will be not applicable, and the second cell will have your degrees of freedom, which you'll need for part E, when we're going to ask about, kind of do a hypothesis test on one of your coefficients. And then the last row is going to have 2 numbers that are both not applicable. So then the next thing, once you have that, is to up here type in your variable names. And the way you want to do that, they should all be right next to each other, but you want to type kind of in reverse order. So if my variables go from PT supply to gas price to west, I first want to type west, and then gas price, and then PT supply. So just in reverse order from the order that they are over here. So kind of mirrored order. So then, oh, and I forgot one more. Type in intercept after your variables because the intercept value is going to show up in this cell. Okay, so the next thing to do is to select this top left cell in our little table that we've created. So underneath the first variable and next to the coefficient in the coefficient row. So select that cell, and actually we're going to select, that's wrong here, select all these cells. So from that first one in the top corner down here to the one that's even with the last row, NA and NA, and the column for intercept. So we've got 4 cells across and 5 cells up and down. Okay, so now you go to the formula bar up here, and you're going to type in, we're going to use this command called linest, linest, then type parentheses, and it'll give you the parameters that it's asking for. So known wise, that's our response variable. So we type in the cells where the response variable is, and don't include the heading, just the values. So it'll start at H2, and in my case it goes down to H63. So you can type that in, or you can select it with your mouse. Now for the known x's, because it's a multiple regression, we're going to want all the cells that include all of these three variables. So the easiest way to do that is to start with the top left cell and go to the bottom right cell. So we'll start with C2. That's where the first value of our public transportation supply variable is, all the way to, this is D, E, west is in column E, so that'll go to E63. So you can do that with the mouse as well, just drag and select all three of those columns that have your explanatory variables. And then just type true and true. And that's just going to give you all the information. It's asking if you want to include the intercept and also get some additional information like the r squared, and then some other irrelevant information. So you've typed that in, then you hit the close parentheses, but now you got to make sure that before you hit enter that you're holding Control and Shift, because that's going to calculate this as an array formula, which will fill in values for all these cells that you have selected. So hold Control and Shift, hold both of them down, and then once you're holding those, then hit enter. Okay, so now it filled in all these values, and you can see, so the ones that we're familiar with in this first row are the coefficients. So this is the regression coefficient for west for gas price, the slope coefficient for west for gas price for public transportation supply, and then this is the intercept value. So let's type out the equation. So I've got a label here for the equation, so I can type that out in this cell, and use the variable name so you can keep track of which is which. So my response variable is commute. I'm going to type commute equals, I'll type the intercept first, negative 1.38, plus now the coefficient for west, 0.49 times west, plus the coefficient for gas price, 0.02, rounding up, times gas price, plus, and then this, you might see this if you get a value, or if you get a variable, one of your variables is very large like this, predicting a smaller response variable, on a smaller scale, you might get a value that's in scientific notation, or you might get a value like this that shows up as 0.0000. And actually here, let's see how you do that. So if this showed up as 0.0000, it might be because it's very small. And so you're going to want to change the format of that. So if you right click on the cell, format cells, and then if it was in number format, it would show up as all zeros. So we want to format it as scientific. So that will let you see that it's not exactly zero, because if you multiply this by these big differences in public transportation supply, then it's going to add up to something. Okay, so now we've got that, and you can just type it in as in scientific notation. So we'll do 2.6 times e minus to the negative 6. So what that means is that really this is it has 5 zeros before the 2, so it's 0.000026. Oh, and I shouldn't put the asterisk there. So that's times PT supply. Okay, so that's our regression equation right there. That's our multiple regression equation. It's the same as the simple regression with one variable, but it just has more variables, and each one gets a slope coefficient. So that's for part A, you have to report the equation, and you also report the r squared value, which is right here. So that's all you need to do for part A, is write this out either in your spreadsheet or on your write-up in Word or another word processing application, and then also include the r squared value, which you'll find right here. So now we're going to jump, because the other stuff is the same on a PC or Mac, so I'm going to make a video about how to get the predicted values that I'm asking for out of this equation, but you can watch the same video. There'll be a video specifically about that. So now let's jump to part E, which is asking you to kind of do a bit of a hypothesis test on one of your coefficients. So the first regression I did was with gas price. That was the variable that I was most interested in. So I'm going to isolate that, and I'm going to type gas price here somewhere below. This is just to keep track. And then in the cells next to it, I'm going to type B for the slope coefficient, then the standard error, the t statistic, which we've started reading about. It's kind of like a z-score. It tells you in standard deviation units how far a value is from either the mean, or in this case from 0, because the mean of the t distribution is 0. And then the p-value, that's what we're really after. That's going to tell us how likely we would see a coefficient value like this different from 0, if we assumed, if our null hypothesis was that the true coefficient value in the population was 0, which basically means, would mean that there is no relationship between gas price and bike commuting. So the way you fill these in, you can actually just grab that value from up here. So that's the coefficient value. You can just type it in, 0.0153. And then the standard error is also in that output. So that's 0.0145. And then the t statistic is actually just the coefficient divided by the standard error, because our null hypothesis is that the coefficient is 0. So in the numerator, we're really taking the coefficient estimate minus 0 over the standard error. So we can just say this divided by this, or you can type the values in. So that's our t statistic. It's kind of like a z-score. It's telling us that that coefficient, if the distribution has a mean of 0 in the population, then this is the where that value falls in that distribution. So it's like 1 standard deviation above that value. And then to get the p-value, you can type in, you can use this function t dist 2t. So it's t dot dist dot 2t, and that actually gives you, that will give you the two-tailed probability, because remember, so this is 1 standard deviation above the mean. So what we're interested in is what's the odds, or what's the probability of having a value that extreme, so that far from 0 or farther. So we're interested in both tails, kind of above 1.05 and below negative 1.05 or 1.06. So to calculate this, you just type this function t.dist.2t, then open parentheses, and you're going to insert the value for x is the actual t-score, the t statistic. So then the degrees of freedom here comes from this part of the output, so it's 58. So you just take whatever's there, and it says deg freedom, but that's just degrees of freedom. Type in 58, and that gives you your p-value, and that's just telling you that if there was really no relationship, if this coefficient is really 0 in the population, we would only expect to see this coefficient estimate about 30% of the time. So that's pretty common. Usually, or that's pretty likely that we might see a coefficient that different from 0. So this doesn't really provide very strong evidence that there's really an influence of gas price on biking, on bike commuting. Usually you'd want a value of about 0.05 or less than 0.1 to reject your null hypothesis.